Let's take a look at G-SRT.A.3. This is dealing with worksheet number 3, where we begin to we've established the criteria of similarity, either AA or SAS proportionality or side-side-side proportionality. And now we're going to formalize, for the most part, a two-column proof as a way to organize our thoughts. And I'm not going to necessarily do one here. I'm going to do a couple under the Elmo here in a minute, and you'll see that. I want to just talk about the structure of this. We've already done proof structures with angle, side, 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 and congruence reasoning. And I want to kind of parallel the thought. So the fact that we've already done that allows this to be a much simpler process. What I have here is kind of what I would say are the three things that might get asked of you to prove in a similarity environment. The first of which, of course, is prove that they're similar. If that's what they're asking you to do, of course, you want to put the given and establish one of these three things happening, usually by AA. And so you're going to put in those statements and then eventually say triangle ABC is similar to DEF. And you'll give one of your reasons. Let's say it was by AA. That may be all that's required of you, and you're done. But if they ask you for a proportion or even an angle that you didn't know beforehand, you would have to go another step to name that proportion or to name that angle that comes because of similarity. This is a lot like CP/CTC. In other words, corresponding parts of congruent triangles are congruent. So once things we found to be congruent, we knew things about their parts. Same thing here. Once we've established similarity, we know things about proportional sides and equal angles. In this case, they wanted us to establish a proportion. And so we would do that. And then our reason would just simply be proportional sides of similar triangles. Now, they don't have some sort of CP/CTC for this. I think you and I probably should sit down and think one up. I kind of just use the symbol sometimes to say because the two triangles are similar, which is kind of what this is summarizing. There may be one more step required of you usually for the third type of proof line. You can see that it is in a product form, not in its proportional form. And you and I both know the way you go from here to here is to simply cross multiply. So to move it from the proportion to the product relationship, you would probably do a cross multiply or something to that effect to explain the procedure of multiplying out and putting it in product form. This is the main idea. Sometimes you get to here, sometimes you go another step, sometimes you go one more step. But basically the idea follows a very similar logical structure to congruence. Let's take a look at some.
Proofs of similarity go a lot like proofs of congruence, but just have slight differences. The good news again is most of these proofs end up being AA proofs, just for simplicity's sake. And so they give me an angle. If I could find another angle, I'd have an AA proof, and of course you and I know vertical angles are equal. ABE would be congruent to DBC. Vertical angles are congruent, and so these are equal. And now I'm ready to say triangle ABE is similar to DBC by AA. You don't get nicer stuff than that. Here they give us that two angles are right angles. Let's make sure we know who we're talking about first. ADC, so kind of this triangle here, do you see it? And then B, let's make sure, AD, oh yeah, okay, and then ABE also, so kind of this one here. Now what I notice immediately is they both have a right angle, that's given. And so we know angle ADC is congruent. ADC is congruent to, they called it BEA. I'm going to go the same way though. I'm going to go AEB. Those are congruent because all right angles are congruent to each other. Right? They all equal 90. They have to be equal to each other. I need one more angle. It's this awesome angle right here. I love a common angle. It's just so nicely hidden in the diagram. You know we don't call it common angle. That's the reflexive property whenever something equals itself. And now I'm in business with triangle ADC congruent to triangle AEB by AA once again. Let's see if we can get a different kind of proof. Now immediately by the given, actually the given tells us parallel lines. Okay, and then this gives us a proportion this time. So if you want to prove a proportion, what do you want to prove first? Similar triangles. This is kind of like CPCTC back in the congruence days, but basically once a set of triangles are similar, then their proportions are also active, right? So they give us some angles, some parallel lines, and I'm just going to list some angles to get similarity. Angle S is going to match G because parallel lines give me alternate interior angles that are congruent. I'm going to name R to be the same as T because parallel lines give me alternate interior angles that are congruent. I'm going to name these guys to be congruent. The triangles SQR is not congruent. Similar, sorry guys, SQR, GQT, triangle GQT. It's a similar symbol if you can't read that. And the reason is AA. Now once they are similar, I better add one more line. I probably could have done this part all in one line, but it's okay. Now I want to name that Q to R is to Q to T as Q to S is to Q to G. And that's because proportional sides of similar triangles. Now, I don't know, there's probably some sort of CPCTC thing for SPCC, SCC, I don't know, but anyways, I just summarized it. And then notice here that we have some sort of multiplicative statement. Now I want to show you something. If we can prove similarity, and then we can say that there's a proportion, all this is basically multiplying out that proportion. So really it's this proof with one more line to make a product out of that multiplicative situation. So they give me an angle, and then I notice right away that angle H is in both triangles that I'm interested in. That, of course, is the reflexive property. And now I have two angles, AA. So I say triangle. Let's see if we can get our name right here. HIJ is similar to H. Now I went H, so to I the dot. So I go HG. F, so AA. Now that they are indeed similar, I can state a proportion. Now, what proportion do I state? I want to use the things that are in this statement. So I'm going to say HI will be to HG. And I also want to use another side in here. Let's see, not HI, I used it already. JI isn't in the statement, so I want to use HJ. HJ is the same as HF. And that's just, again, proportional sides of similar triangles. And the last thing I'm going to do is I'm just going to cross multiply that. and I get the statement that they had. And I place down cross multiplication. You might just say the multiplication division property, where basically you're multiplying both sides, but I just basically state the multiplicative process there.